Okay, the direct stiffness method for linear static analysis. So in this course is divided into 5 sections. In the first section, we're going to get introduction to the direct stiffness method and the predecessor methods of this method. We're going to know a little bit about material properties as well here. Okay, and then in section 2, we are going to be looking at the essential formulations and sign conventions that are going to be used throughout this course. And the number of lectures in the sections are 2. In the first lecture, we're going to be learning about stiffness, and in the second lecture, we're going to talk about joint displacement and forces. And in section 3, we're going to learn the direct stiffness method for 2D trusses. There are 10 lectures in total in this section. So in this section, we're going to be learning the stiffness metrics. We're going to learn the development of the stiffness metrics for 2D truss in local axis system. And then we're going to see the transformation of stiffness metrics from local axis to global axis. And right after that, we're going to see how to use global metrics to get local stiffness metrics. And after all that, we're going to be seeing the assembly of stiffness metrics and load vector for a 2D truss. And after that, we're going to see how we can use the equilibrium of joints to get the same stiffness formulation that we're going to see for the assembly of stiffness metrics and load vector of a 2D truss. Okay, and right after that, we're also going to see the zero force members, how to determine the zero force member for 2D trusses. That's just going to be a short note, not an extensive discussion. And right after that, at the end of this section, we're going to be doing a practice problem. And also we're going to be seeing what can be easily done by hand. Okay, so to do the direct stiffness metrics or to do the finite element analysis, we usually need softwares or we need to know programming languages. But in this course, in this section, we're going to see what we can easily do by hand without the help of software or programming languages for in the case of 2D truss. Okay. Alright, right after that, in section 4, we're going to learn the direct stiffness method for 2D frame. So there are also 10 lectures in this section, and in this section we're going to be seeing the stiffness metrics for 2D frame. We're also going to be seeing the transformation of stiffness metrics from local axis to global axis for 2D frame. Then we're going to be doing example problem. At first we're going to do the example problem, and then we're going to do the example problem again, but that time we're going to be neglecting the actual deformations, and we'll discuss why we're doing that as well. Okay, right after the example problem, we're going to be having 2 practice problems that we're going to be solving using the metrics method at first, and right after that we'll also be solving those problems for the equation method. Okay, or using the equation method. We will also be understanding the joint load vector use in 2D frames, and we'll also be going to take a look at the equation method for 2D frames, all kind of 2D frames. Okay. All right. Right after that, we're going to have the last section, which is section 5, the 3D truss. We're going to learn the direct stiffness method for 3D truss. So the number of lectures in this section are 7. There are 7 lectures, and in this lectures we're going to be taking a look at how to determine the zero force members for a 3D truss, and then we're going to see the stiffness metrics for 3D truss, and we'll also learn how to determine length of a member in 3D space, because we're going to be needing that if we want to solve problems. And we're also going to take a look at an example problem, and the example problem is actually divided into 3 lectures. In the first example problem lecture, we're just going to be determining the zero force members of a 3D truss, and in the second part we're going to be determining the stiffness for a single member, and then in the third part we're going to see how we can determine the stiffness for all of the members and how we can easily formulate the metrics for a 3D truss without the use of any softwares or any programming languages. So since we're going to be doing everything by hand, there are going to be some limitations, but we're going to see how we can maximize the direct stiffness method by using the hand calculations only, without using the software or the programming languages. What we can do without the softwares and programming languages of the direct stiffness method. Okay, so this course is actually for understanding the direct stiffness method. So, and by doing hand calculations, you will get a better understanding of the direct stiffness method. And once you're done with the course, you can move on to do the direct stiffness method using the help of software or using the help of programming languages. Okay, and in the upcoming courses, if we do continue the direct stiffness method courses, then in the upcoming courses we're also going to get introduced to programming languages for solving the direct stiffness method, for using the direct stiffness method. Okay, so yeah, that is all in this course. I hope you're going to do the course and you're going to find the course very helpful and enjoyable. Thank you very much for watching.